In this video, I'm going to go over this organic chemistry problem where we're going to see that we have a secondary amine here reacting with excess CH3I, K2CO3, and H2O in the first step. In the second step, we have Ag2O, H2O, and heat. So when you see an amine reacting with these reagents, this is a big sign of Hofmann elimination reaction, where we're going to create the less substituted alkene, right? So this amine right here would become over-methylated with this excess CH3I to become this product here, this intermediate here, where we do multiple steps until this nitrogen has no more hydrogens and is positively charged with 4 R groups attached to it. Now, the Ag2O comes in the form of hydroxide ion, but because this amine is very sterically hindered, this strong base here is going to do an E2 reaction in the less substituted beta carbon, right? So this is a tricky part here because we can see that this carbon here is the alpha carbon, this carbon here is the alpha carbon, alpha carbon, alpha carbon, because it's the first carbon away from the nitrogen right there, right? And we see that these carbons here are the beta carbons, right? Where this beta carbon here is tertiary, this beta carbon here is secondary, and this beta carbon here is primary. This is a very sneaky one because a lot of students forget that there's 3 hydrogens here and it's outside of the ring as well, right? So this is the beta hydrogen that we're going to grab to form an alkene for Hofmann elimination like this. Right, so this hydroxide ion is going to grab that beta hydrogen. This bond between the hydrogen and carbon is going to go over here to create a double bond between this alpha carbon and beta carbon. And then this bond here is going to break off and kick off that good leaving group right there, giving us this intermediate here, right, where we see a double bond right here. And because this nitrogen here has a lone pair of electrons, this lone pair of electrons is going to act as a nucleophile, attack another CH3I, and become over-methylated again, which becomes this intermediate right here. And then now our final step here is to bring in another hydroxide ion to get this beta hydrogen, make a double bond there, kick out this leaving group, and lead us to our final answer here, where this trimethylamine here will become neutral if we are still in basic conditions, but if you are in solution has excess CH3I still, this lone pair of electrons will attack another CH3I, becoming over-methylated, becoming this ammonium ion there. And I hope that helps. If you want more help and hang out with me, come join my office hours in my Linktree.